Hello, Year 8. Here are the answers for the structure of the atom part 1 lesson that you had on Thursday of this week. I was so impressed at how much effort you all put into doing this piece of work, so well done. First slide asked you to type some things you remembered about the periodic table, and you remembered lots of fantastic things. I can read some out to you if you would like. The periodic table goes with numbers and letters to make things. There was elements. It was created by Dmitri Mendeleev. The horizontal rows are called periods. The vertical rows are called groups. Mendeleev made it. There were 7 groups, 8 groups, lots of different elements, lots of different shortened words, so symbols for the elements. There were 118 elements in the periodic table. All the letters stands for things like aluminium and silver. So fantastic ideas that you came up with there. Okay, and then I asked you to remember some words that we had covered in previous lessons. So atoms are small particles from which all substances are made. Elements are substances made of only one type of atom. Compounds have 2 or more elements chemically combined in fixed proportions. And properties are how a material behaves and what it is like. And then I asked you about the 3 scientists that we looked at in the last lesson about the periodic table. Dobereiner, he was the one that came up with the triads, the groups of 3 elements that had properties in common. Newlands was next, John Newlands, and he was the one that noticed every 8 elements there was something in common, so he had his law of octaves. And then Mendeleev, Dmitri Mendeleev, he was the one that left spaces for undiscovered elements and changed the order if the pattern didn't fit. Then I told you about some more scientists. So this is Democritus. He lived a very, very long time ago, 460 years before Christ. And he thought the universe was made of empty space and tiny bits of stuff. But he thought that if you started cutting that stuff into pieces, half and half and half, that eventually you would reach a point where you couldn't divide it anymore. And he called this bit of stuff atom, or atomus, which was the Greek word for indivisible. So Democritus thought if you cut stuff up, eventually you'd reach a point where you couldn't cut it up anymore and it would become indivisible. The next scientist, and we're talking like 460 plus like nearly 2,000 years. So we're talking 2,400 years later. At the start of the 19th century, John Dalton put forward his idea. Hi, my name's John Dalton. In the year 1909, I think atoms are solid spheres. So the words that are highlighted here are the words that you weren't sure of. So if you remember back in when you learnt 3D shapes in Key Stage 2, a sphere is like a round shape, a ball. So it could be a football instead of a snooker ball. So John Dalton thought that atoms were like footballs, but that they were solid in the middle. Footballs are obviously filled with air, so that's why we don't use it as an example. Snooker balls or pool balls or billiards are solid hard balls. Okay? And he thought that every element was made of a different type of atom. The next scientist was J.J. Thompson. And he put forward his plum pudding theory after discovering something called an electron. I'm wondering if I've got these dates muddled up. 1909, 1897. I think I've got those dates muddled up. So, but the people are important. He made an important discovery that the atoms were not solid spheres. So they were not solid balls. And he made some measurements and he found out that some of them had negative charges. So if you've ever rubbed a balloon up against your hair and it's made your hair stand on end, that's because it's transferred charges from the balloon to your hair or your hair to your balloon. And then that causes an effect. So basically he did some measurements and he found out that there was charges inside of the atoms. And he concluded, so your conclusion is what you say you found out after your experiment. He concluded there must be something inside the atom. He decided he was going to call his model the plum pudding model because the electrons were spread out like plums in a pudding. Now, we in this modern age don't often eat plum pudding. So, which is why I mentioned the chocolate chip cookie. So if you think of a chocolate chip cookie, the chocolate chips are spread throughout the biscuit, but the biscuit is still quite solid. And he thought that the biscuit part was like a positive charge, and the electrons were like the chocolate chips that were spread throughout. Okay, so just a little summary. Democritus thought that everything was made of indivisible bits, and he called them atoms. John Dalton thought that atoms were like solid balls, or are solid like balls and full in the middle. And then J.J. Thompson found out that atoms have something inside with a negative charge, and he called them electrons. Okay, so if we look at a picture of what these would represent, Democritus and John Dalton both thought that the atom was like a solid ball. So both of those top two would go to the top picture. And J.J. Thompson was the one that thought it was a ball of positivity with negative electrons spread throughout. So a little summary, and now I can see actually on these two dates why you quite a lot of you got them muddled up, and that was my fault. I got them muddled up on the first two slides. Okay, but it does go in time order. So Democritus said atoms were indivisible. John Dalton said atoms were like balls. J.J. Thompson discovered electrons, and he named his model the Plum pudding model. And then a little bit of revision about solids, liquids, and gases. So in solids, the particles form a regular pattern, which explains the fixed shape of a solid and why it cannot be compressed or poured. In liquids, the particles still touch their neighbours, but they move around, sliding over each other, and this is why you can pour but not compress a liquid. In the gas state, wildly spaced particles move around randomly. This explains why you can compress gases and why they flow. And I asked you to draw what you thought the atoms would look like. So in a solid, they're in a fixed regular arrangement, which is why solids keep their shape, keep their volume, cannot be squashed and cannot be poured. In a liquid, the particles can slide past each other, but they're still touching. So you can't squash a liquid. There's no space between the particles to squash the liquid, but you can pour it because the particles can move over each other. And in a gas, the particles are spread far apart, and that is why you can compress a gas. You can squeeze it together because there are gaps between the particles. Then we just went through those keywords again to remind you. Atoms are small particles from which all substances are made. Elements are made of one type of atom. Compounds have two or more elements chemically combined. And properties are how materials behave. Okay? Dobereiner was the scientist that came up with the triads in the periodic table. Newlands had his law of octaves, every eighth element having a property in common. And Mendeleev was the scientist that left spaces for undiscovered elements and rearranged the order when he needed to. Thinking about today's scientists, Democritus, everything is made of indivisible bits. We'll call these atoms. John Dalton said atoms are like balls and full in the middle. J.J. Thompson said atoms have something inside with negative charges called electrons. So thinking about these two models, Democritus and John Dalton had a solid ball. J.J. Thompson, a ball of positivity with negative electrons. And then the last slide, I asked you to pretend your friend was absent from class today. What would you say if you had to explain what you have learned? So I was very impressed with your summaries. I'm very proud of how hard you're working. Keep up the excellent work, and I will see you in the next video.